Okay, in Module 3 there are three major components or concepts we're going to learn about. This lecture is on the first one, which is conversions of measurement, and that's also found in Chapter 9 of the book. The other two lectures, which are coming up, lecture number 2 and 3, are not found in the book, so you're going to be dependent upon those lectures and the handouts that I put on Blackboard. Let's get started on conversions of measurements. First thing we're going to do is just deal with converting measurements within the metric system, which is simple because everything in the metric system is based on multiples of 10. So if we wanted to change to a smaller unit, you can see what it says right here. We just move the decimal point to the right. So this is the same as multiplying by 10 by 100 times 1,000. If we move to the left, we divide by 10 or 100 or 1,000, etc. Now, most students learn best by example, so let's take a look here. This says convert 23.145 liters to milliliters. Well, here's liters on our chart, and to convert that to milliliters, we have to multiply by 10, 100, 1,000, or better yet, move the decimal 3 to the right. So when I move this decimal 3 to the right, I simply get 23,145 milliliters. And that's how easy it is to convert within the metric system. So let's say that I wanted to convert 52 centigrams to kilograms. Well, the decimal's right here, right after the 2 in 52. So to change centigrams to kilograms, here's centi. I need to move it to kilograms, so I have to go once, twice, 3, 4, 5 times to the left. So I'm going to take this decimal, when I move it 5 times to the left, once I've moved it twice, I need to start adding zeros. So 3, 4, 5. I bet you agree I need to put point and then 3 zeros, and I'd have 0.00052 kilograms in 52 centigrams is the same as, what would that be, tenths, hundredths, thousandths, 52 100,000ths kilograms. And I'm going to make my pen a little bit thicker, so hopefully it doesn't disappear on me like it has been. Okay, let's jump to this slide. We'll just do a couple more examples of these so we have time to get to more of the difficult stuff called dimensional analysis. Let's do this one right here. 11.2 centimeters is how many meters? Well, here's centi, and we need to get here to meters. So I've got to go 2 to the left. So I take this decimal point right here and go once, twice, and that gives me 0.112. Excuse me. Let's pick another one. How many milligrams are there in 25 centigrams? Well, here's the centi, and I want to go to milli. So to go from centigrams to milligrams, I have to go 1 to the right. So I take this invisible decimal here and move it 1 to the right, and there are 250 milligrams in 25 centigrams. So I hope those examples help you when converting in the metric system. Everything else in this lesson we're covering today, we're going to be talking about using dimensional analysis. And dimensional analysis, some teachers call it the labeling method. It just helps you convert units of measure by basically canceling out units of measure, which you'll see here in a second. Before we learn about dimensional analysis, it'd be helpful to remember something really easy. If I take 5 and I divide it by 5, well, any number divided by itself is 1. In other words, it cancels or simplifies to give me 1, doesn't it? Well, even if I put units of measure like 8 feet divided by 8 feet, that also cancels or simplifies to give me 1. In fact, if I just had a mile over a mile, that simplifies. 1 mile divided by another mile simply gives me 1. You'll see where this is going to help us on the next slide. So if I told you guys to multiply this long fraction problem here, I could multiply all the numerators and multiply all the denominators and then simplify my answer, but it's easier to do this. Any numerator that's equivalent to a denominator, I can simplify it to equal 1. So these two cancel out to give me 1. The 9 up here and the 9 down here simplifies to give me 1. So I'm simply left with 5 times 2 on top, which is 10, and 11 times 3 on the bottom, which is 33. So watch how this helps on this next slide. Okay, convert 2 miles to feet. Now I know that for most of you it's just second nature what you do here, but I want to show you, and like I said, notice these are easy dimensional analysis problems. I'm going to write down 2 miles, and what I want you to do is hang in there with me here. Come on, pen, don't disappear on me like this. And I'm just going to put that over 1. I don't have to do this, but it will help you understand that the 2 miles is the same as being in the numerator. And I'm going to multiply that by one of two things. Since there's 5,280 feet in a mile, I'm either going to multiply that by 1 mile over 5,280 feet or 5,280 feet over 1 mile. Now what even allows me to put 5,280 feet over 1 mile? I can do that because I'm multiplying by 1. I know this might not look like 1 to you, but it is 1 because 5,280 feet is exactly the same as 1 mile, and anything over itself is equal to 1. So I can take anything times 1 and get what I started with. Now here's what's nice about this. Watch what happens here. This label of mile cancels out with that label of mile because 1 mile over another mile cancels because it equals 1. So look what I'm left with. I'm left with just whatever 2 times 5,280 is, which I believe is 10,560. And look at the only label I have left is feet, and that's what we wanted, was to change that to feet. Now if you want to take your 1 times 1 on the bottom and put a 1 on the bottom, you can do that, but anything divided by 1 is itself anyway. So there's my answer, 10,560 feet. Now I know you guys probably knew that way before I got to that answer, but I want you to understand the method before we get to the more difficult ones. So convert 18 quarts to gallons. We're going to put 18 quarts. I'm definitely going to label this. That's supposed to just be QTS. Okay, 18 quarts, and remember I'm going to put that over 1 to help me remember that's in the numerator. Now I'm going to multiply that by either 1 gallon over 4 quarts or 4 quarts over 1 gallon. I want this quarts right here, I want that to cancel. Well, the only way to get that to cancel is by putting the 4 quarts on the bottom. So I have 1 gallon over 4 quarts. Now, like I showed you before, now this quarts and this quarts cancels, and the only thing I'm left with is gallons, and that's what I wanted, was gallons. So if I haven't made it clear yet, all you do is you look at the conversion and you decide which one goes on top and which one goes on the bottom. And the way you decide is you want this up here on top to cancel with this on the bottom. So we had to put the quarts on the bottom in order to have that happen. Now what am I left with? I'm left with 18 on top, and 1 times 4 is 4 on the bottom, and 18 divided by 4 is 4.5 or 4.5, and my only label left is gallons. So my answer is 4.5 gallons. Let's move on to a more difficult problem. These still aren't that difficult, but they're a little bit tougher. By the way, all these conversions that I'm writing here, and I should have told you that at the beginning of the lecture, there's a handout I put out there on Blackboard. It's a 2-page conversion handout. It's straight from your textbook. I just consolidated them all into 2 pages. Use those to help you on any conversion problems, like on your test coming up. Okay, let's convert 2 kilometers to inches. Well, the first thing I say to myself is this: I don't know how to change kilometers to inches, but I do know that 1 inch is 2.54 centimeters, not kilometers, but centimeters. So what I do is I go back here and I change kilometers to centimeters by doing this: once, twice, 3, 4, 5. I'm going to move the decimal 5 to the right off the bat to change this 2.5 kilometers to 2, and then I'm going to move that decimal 5 times: once, twice, 3, 4, 5. So 2.5 kilometers is 250,000 centimeters. and I'm going to put that over 1. Now, here's the deal. I'm going to multiply that by either this over this or vice versa. Well, I want centimeters to cancel, so my 2.54 centimeters goes on the bottom, and my 1 inch goes on the top. And once again, I'm going to grab the red pen to show you that that centimeters cancels with that centimeters. So what I'm left with on top is 250,000. And what I'm left with on the bottom is 2.54. And the answer would be, let's grab the calculator really quick, 250,000, whoops, I better just use my, there we go, divided by 2.54. Okay, it's about 98,425. About 98,425. I'm about out of room here. Inches. Sorry for squeezing that in there. Okay, let's do the one down at the bottom. Let's change 2.54 to grams. Let's change 24 pounds to grams. So I'm going to put 24 pounds over 1 times, now I want pounds to cancel, so I'm going to put this 1 pound on the bottom, and I'm going to put 0.45 kilograms on top. So look what happens here. My pounds cancels, and I multiply, take 24 times 0.45, 24 times 0.45 gives me 10.8. So notice though, my answer right now is 10.8 kilograms, and I wanted to know how many grams. So I go back to here to change from kilograms to grams. Notice I did move it once, twice, 3 times to the right. So when I move my decimal 3 times to the right, I'm going to get 10, and then I'm going to move it 3 times to the right. It would be 10,800 grams. Okay, looks like we have time to get one more in here. Let's do 56 feet per second. We're going to change 56 feet per second. So that's 56 feet over 1 second to miles per hour. Well, the first thing we want to do is get rid of that feet. We know there's 5,280 feet in 1 mile, and I wanted to get rid of that feet, so that took care of that. But I don't want seconds, I want hours. Well, you might remember this. There's 3,600 seconds in an hour, because there's 60 seconds in a minute and then another 60 minutes in an hour. So look at, now my seconds cancels with seconds, and the only 2 labels I'm left with now are miles on top and hours on the bottom, and that's what I wanted. So I'm simply going to take 56 times 3,600 on top, and then I'm going to divide that by 5280. So 56 times 3,600, 56 times 3,600, and then I'm going to take that answer and divide it by 5,280, because that's what was in the denominator. So it's about 38.2. It approximately equals 38.2. And once again, all I'm left with is miles and hours. So that's miles per hour. Okay, see my handout for more examples on that, or actually check chapter 9 in the textbook for more examples on dimensional analysis, and then the handouts for the other 2 lectures for more information. Thanks for watching the lecture, and good luck in this module. Bye.